You're saying you just want to do a batch processing?
No, I'm not saying batch. I want to see maybe, like as the audio is coming in, maybe I need to see enough to be able to conclude something.
Maybe what you would do is kind of like how, remember the old compact disc players when they first came out for car audio? They used to skip all the time, and then they decided to do oversampling, where they would listen to the same part of the song multiple times and take the ones that matched up the most and say, these 14 reads matched up, these 2 or 3 didn't. I'm going to throw those in the garbage and keep this. So maybe you could do an offset oversampling where you listen to, 9 seconds, and then you listen, from second 0 to 9, and then you listen to another 9 seconds from second 2 to 11. And so you've got some overlap in there in the processing, and you see what I'm saying?
So then those units, the tick unit typically is in a second range?
It totally depends.
Okay.
But you can set it for longer, right, in her case?
Right,
Well,
in your case, you could
set
either
it
set it
for
for 2
2
minutes
minutes
or 5 minutes or whatever.
Yeah.
But I'm saying if you're
That
concerned
works.
about the time, you could take 10 small chunks and have them processed by multiple nodes and then reassembled afterwards. And the parts that overlap that agree, you know what I mean, are the parts you keep on moving with, and you can kind of rebuild your stream of consciousness, if you will.
I got it. I think that's a good idea, because then I can just quickly do it and then emit out, and then at the reassemble time I can know whether it's good or not at that time. So throw away. I will do the garbage picking at that time.
Yeah, and you can also set the interval for the tick tuple as long as you want. Set for an hour.
But then it's kind of no longer a
Real time.
real-time thing.
Right.
You can still get queuing though, right?
Yeah, well, if you set the tick tuple that widely spaced out, it will still be doing a lot of aggregation. You'll save data in memory, presumably, for something like this. But yeah, so in normal scenarios, you wouldn't have a tick tuple that spaced out, but even an hour, 30 minutes, depending on your use case, is totally normal.
Bottom line being, that's more like as you do it, you kind of, over time, after you do a little bit, you know what to set, right?
Yeah.
The tick time versus the length of the audio, you kind of, meaning there's no smart built-in that will do it automatically.
Yeah.
Now, I was thinking, this function is taking too long, let me spill out from a few more.
Yeah. Yeah. That kind of intelligence is not built into it yet.
Okay.
So yeah, you do have to play around with processing tick tuples and scale, size of the cluster.
I have a question, Brandon. So, let's say token counter is restarted, so all those messages will be restored, all those messages will be processed again.
If the token
So
counter
then
is,
what, like sometimes for there is a separate service and token counter is a separate service, right?
yeah,
If token counter shut down for a while, so when we restart the token counter again, the message will be processed again, whatever the message is lost during its shutdown.
so it's not like a standalone service. These are just instances of classes inside JVMs across the cluster. You do have instances where you have an exception and the task could crash, or you've got a server that goes down. And so a couple of things happen in that case. So one, you're going to lose whatever data you have in memory, and there are ways to remediate that, which I'll touch on later. But one thing you do as you're processing tuples is you explicitly ACK or fail the tuples, and there are ways to do that. So if you don't ACK the tuple, the upstream components will resend that. And so, so say for example, you're saving every 10 messages that come in and then writing those in a batch to a database, and you only ACK all of those 10 tuples when you actually save to the database. If your component crashes before it saves to the database and never ACKs, then Storm will resend those tuples back after automatically restarting your component. And so it has this built-in resiliency as long as you're properly doing the hacking and failing of
kind of acknowledgement the producer will receive once it is data stores in it.
Yes. Yes.
What about in case of like multiple clients listening to the producer? Like multiple clients. In this
Yeah,
case, only
yeah.
the program has one client. There could be another client using to the same producer, right?
So, yeah, so you can have n number of downstream components listening to a single upstream component. They all get a copy of the output of that component. And so what Storm is building internally is essentially a tuple tree. And there's acking that happens at every level. And so what Storm really does is work that out for you. So even if, you have 10 clients listening to one component, if one of those components crashes, Storm will be able to resend whatever tuples that component missed. Okay. Cool. Okay. So going further with that, actually, so as you're doing aggregation in Storm, so you're holding the data in memory if your component crashes, or if you need to restart your topology, so maybe resubmitting a new version, you're going to lose whatever data you had in memory. And so one way to fix that is to externalize your data storage or an external data cache. And so one thing that works pretty well is using Redis. And so as tuples are coming in, if you need to have a substantial cache, you just externalize that to Redis so that you can freely shut down, restart your topology, and all your state is still there, persisting in Redis. In terms of other use cases, so in real-world scenarios, you're typically reading from a queue. Kafka is very popular. Kinesis is a big one as well. And both Kafka and Kinesis have acking/checkpoint functionality that can integrate with Storm. So even if the entire Storm cluster fails and never acts the message that it got from Kafka or Kinesis, Kafka and Kinesis will resend that to Storm. And so that's kind of cool for getting resiliency in the entire analytics chain. Other patterns that people use. So if you're doing a lot of persistence with Storms at a very granular level, typically you need a high write performance data store like Cassandra to be able to handle just a huge volume of messages coming in. Doing multi-stage MapReduce is really simple in Storm. And for this group, for anyone doing data science, plugging in a framework like Weka into Storm would be really interesting to do some online learning. At Expedia, so the big thing that I'm working on is travel market analytics. So looking at real-time clicks happening on Expedia.com to figure out patterns in the data, who's looking at what. A big use case for hoteliers is to figure out who their competitors are or who's shopping them. You can also do things like real-time ad targeting. As users are clicking around the website, you can figure out what they like and what ads we might want to show to them. And then also, another great use case is just real-time system monitoring. Doing sliding windows for average response time or TP99 on a specific service. And then also, if you're a person who hates Java, you can use Python or Ruby. Storm has like a multi-lane API, so you can use whatever language you want. Right, so that's what I wanted to share today. So a couple of the other frameworks I mentioned, Trident and Summonbird, are a couple frameworks that sit on top of Storm to do some higher level abstractions. I've got some information on standing up your own Storm cluster if you wanted to try that. Otherwise, I have my contact info. Please reach out for any questions. I'm really interested in the streaming analytics space, so I'd be happy to talk to anybody about that. And otherwise, any other questions? We can do some hacking in the example. word count to try out a few things. Just open it up for more discussion.
Brendan, can you, on your code example, can you show the role of zookeeper?
In this example, so Storm is handling that all for me,
Mhm.
and so I.
I'm sorry, what was the question?
What is the role of zookeeper in his example?
Okay.
So in this case, Storm handles that for me, and I'm running it in local mode here, so I'm not actually sure it's actually using zookeeper in this example.
If we were to put it on an actual cluster.
So in that case, you just have to configure Storm to point to your existing zookeeper cluster.
Okay.
Actually, one example that I was wanting to put together was actually doing some streaming audio processing using a Fourier transform, and wanted to get that plugged into Redis and column charts so we could do like a real-time spectrum analysis, but didn't get that plugged in.
That'd be super cool.
Homework tonight.
Yeah. Yeah, and that would be really interesting to see what the runtime performance of the Fourier transform is, to see how large of a data set you could do that in a true streaming fashion before it started taking longer and causing backups in the actual chain.
Brendan, could you bring up the slide that showed your, like the boxes? Yeah, the one with the boxes on the bottom, right? So in this case, if it's streaming, right? So let's say on the left is, like click stream, like you're talking about, someone, you get thousands of clicks happening.
Yeah.
And so they're coming in, let's say for a particular, for users.
Mm-hmm.
And let's say one click is just a line, right?
Yeah.
Each action is a line.
Yeah.
And so they're coming in thousands per second.
Yeah.
And then you say, hey, I have a tokenizer, and I say run 10 instances or 100 instances. So you're saying when it comes in, it takes each line and pass it out, maybe round robin, to each of the task instances? Is that how it works? And then
Yeah, you mean like the token counter?
yeah, like a sentence tokenizer
Yeah, yeah. So the Storm framework itself would handle.
would split all that up.
Yes.
Okay, and then run it all in parallel.
Yes. Yes.
Okay. And then at some point, let's say at the end, you're saying, hey, if let's say a specific user does this sequence of things, show them this ad, right? Let's say.
Yes.
Let's say if they click on, they look at 6 property, 6 hotels, show them this ad, right? So would that be, how would that work? So you have thousands coming in, so then you would have a second step like a counter that says, hey, for this user, if you spot this pattern, emit something. I mean, how would that like?
So yeah, so as the messages are coming in,
Mhm.
so you figure out who the user is. So pull the user ID out,
Mm-hmm.
and then probably do a fields grouping on user ID so that you have all the actions of a particular user going to the same goal,
Okay.
so that you can keep track of what they're doing.
Mm-hmm.
Or you could also externalize that to a separate store like Redis.
So you maintain state. That one
Yes.
task will maintain state for that user and
Yes.
keep accumulating. Okay.
Yeah, so then in that case, you can keep an external data store to say, for this user, what list of hotels have they seen?
Mm-hmm.
And then, later when another page is rendering, it would need to interrogate that data store to see what that user has seen, and then make it ads decision based on that, as an example use case.
So if they've clicked on a lot of Weston and Sheraton products, you might show them a Starwood Amex ad. Like, sign up for the Starwood Amex.
Yes. Yeah, but that's dependent on the whole ad targeting model.
Right. And then typically it's like, hey, you watch for what, a user session, like, and if you don't see any more clicks, you assume they're gone and throw it all away. Is that kind of how?
You have to have some kind of expiration.
There's some sort of expiration, or you
Yeah.
accumulate for a day, or like?
Yeah, for that use case, yeah. So in a certain use case, I'm keeping track of all the hotels that all users have seen. And Expedia gets a lot of traffic,
Mhm.
so that can grow pretty large. So in that case, I'm just using Redis with key expiry. And so that says if I don't update that key in Redis in X hours, just throw it away. So Redis handles that for me. I could just do it in memory in the vault using like Google Guava as a cache
Mhm.
to handle expiry for me.
So when a new key comes in, it doesn't find it in Redis, then a new task is created for that?
No, good clarification. All the tasks that will ever exist are created on topology startup. And
So
so
there's no overhead for creating another mapper or a user
Well,
at runtime?
there is some. I mean, you're ultimately just creating more objects that are going to live in memory in the JVMs. But because of the way aggregation happens in Storm, you can't dynamically change the number of tasks.
Mhm.
And so if you run into some situation where you need more tasks to spread out the whatever processing you're doing, you might need to reconfigure your Storm topology and redeploy. But there are certain cases where if you just need more processing power, you can increase the number of worker JVMs and machines. So like add supervisors to the cluster and then tell Storm to rebalance the cluster. So say for example, if your processing is CPU bound and you just need more machines, you can just add a couple more machines and then Storm will redistribute the processing. And that happens with minimal interruption in service.
Since I just mentioned it, the original hardware demo, I was thinking about the cluster was populated dynamically or statically. See if you want to add on a couple of processors or even a couple of servers. Say you want to add 10 more servers,
Yeah.
add on all instant applications. Do you have to stop and start to populate it, or you can dynamically populate it over additional cluster?
So you mean, so in order to
Hardware-wise.
hardware-wise, adding more servers?
Yes.
Yeah, you don't have to stop the topology. You don't have to stop the cluster. You basically tell Nimbus. You tell Nimbus that you have a couple more supervisors available for it, and so then those get added to the Storm cluster, and then you tell Nimbus to rebalance your topology across all available supervisors.
That's at the software level, right? If you want to add more servers, it's hardware level.
Yeah.
So you're using virtual machines, or if you're using AWS, it's all a separate
It's separate.
task,
It's separate.
right? This doesn't know about that. You have to, let's say you add 2 real machines, you have to prop up those machines,
Yeah.
and then run the software on that, and then expand.
Yeah, because
Supervisors are-
at the
it's
beginning of this, the whole session, he said, nowadays, the people using less sophisticated machine, but run in the cluster mode.
Yeah.
So that's the question pop up, when you add more machine in, then what will happen?
Yeah, so in AWS, you would spin up two more EC2 instances, let's say, and then you kind of set that up and then tell Nimbus about it, right?
Yes.
It's 2 separate tasks, kind of
Yes.
distinct layers.
The point being is the service would keep running while you're doing this.
Yes,
Yeah. That maybe a queue would build up or something.
correct.
Yeah, it might have a few seconds of downtime as it's redistributing work, but it's not bad. Storm doesn't support this right now, but it would be awesome if it could dynamically detect, like, if the topology is running at some maximum level, like CPU is getting too high in the boxes.
To call and say,
Automatically.
spin me up the
Yeah,
All those,
EC2.
yeah. So that I don't think Storm handles that yet, but a lot of people are thinking about that.
This is open source, right? So somebody's probably gonna write something that does that relatively quick and then hang it out on their blog, right?
Yeah.
Open for a couple of years.
Yeah.
Yeah.
Kinesis doesn't do that either. It's not a trivial problem to solve. to auto scale. They don't,
Behind the
Kinesis doesn't
scenes.
auto scale. So someone did write a plugin that does it,
Hmm.
but it's not production ready.
Mm.
Yeah, and even with Azure Streaming Analytics, you have to stop the processing to tell it to allocate more processing power and then restart it.
And
So
what about
Kinesis,
take
you
processing
can-
power away?
Kinesis, you can add shards on the fly without interrupting processing. But there's no detecting that CPU is over 80% for longer than 3 minutes and auto spin off more shards and split shards. It doesn't do the auto. But it does, you can go in and say, hey, I have 10 shards right now, I want to add 10 more shards.
Yeah.
It'll come out in seconds, for 10, maybe a minute, and processing continues. And then you go use the new ones as well on the fly. But it's the auto scaling part that it doesn't have.
I can imagine that would be a very complicated process from you could be CPU bound, you could be IO bound, you can be memory bound, and there's a lot of
It probably would
edge
depend
cases.
quite a bit on what type of data you were processing and how you were processing it,
Yeah.
what your choke points are.
Yeah.
Yeah, so you typically end up having to monitor the boxes a little bit to see what you're running up against. So far, most of the processing I've been doing is CPU bound.
So if you change your question or the nature of the data,
Yeah,
then that could change all of it.
yeah. If I start needing to aggregate more in memory, I might hit a memory limit, need to scale up because of that.
So you're in production already?
Yes,
Okay.
yeah. So,
Analyzing all the clicks of Expedia.
yes, yeah. So,
How big is the cluster?
the largest cluster that I'm running, including Nimbus, not including Zookeeper, is 5 servers. Yeah, so
Wow.
it's not enormous yet. However, there's an upcoming project that is going to require about 3 times that.
5 servers can ingest all the clicks on Expedia and analyze it in real time. That's pretty amazing.
Yeah, I think the benchmarking on Storm, I think they've been able to get up to 1 million tuples per second per node.
Huh.
But I think that's excluding any kind of processing that you would do.
Right,
So
do nothing.
Yeah,
It's a no-off.
Just passing it through.
yeah.
How many clicks do you have going through a day, 1 billion, or?
I don't know if I'm allowed to, since
No,
we're recording here.
Actually, I don't think that's actually super surprising, actually. Do you know a real business that's needing, humongous number of servers at all?
Well, I only imagine that
Like,
they
I
have a
actually
lot of
find
click stream traffic, right?
No,
I'm just-
same thing,
Mhm.
for any website, we run our ad business also.
CERN.
Yeah.
Well, I'm sure Expedia has more than 5 web servers.
Oh, yeah.
Yeah, it's usually.
Yeah, years
That's
ago,
not
they
the
were
number
they
of
were in the
PMs.
hundreds of web servers when I was there. I have
That's
no
not
idea
the
what they
number
are
of
now.
PMs.
Probably
That's
less
just the number of
actually, because
supervisors.
servers got better. But
No, it's not that. It's rather if you break down the actual processing.
Mhm.
Basically, because this is also analytics side, I've,
Mhm.
anyway, without getting all into the detail, I could do all the calculation. I actually think that's about right, actually.
Mhm.
Yeah, the type of, the range,
Mhm.
this kind of quick streaming, you don't expect hundreds of thousands of machines that are cranking on some basic accounting.
Mm. Oh, you're saying because the processing is not intensive? Or,
I don't know exactly what's going on, but in general, I don't find, that's not my experience.
Right.
I've not heard any production environment where you run streaming hundreds of thousands of machines.
well, I'm not saying hundreds of thousands,
in
that's,
that
yeah,
range.
but I would think it's more than 5.
I only know of one, the big particle accelerators. They do hundreds of thousands of servers. so.
That's the world traffic.
Yeah. Brendan, can you briefly describe redundancy and how is redundancy built into Storm? Because that's a big topic with Hadoop.
Yeah. One thing on the previous, the first step I'm doing in all of the topologies I'm running is filtering out messages I'm not interested in. So for the processing I'm doing,
Mitigation.
yeah, I'm only looking at a small subset of all messages going through Expedia.
Okay.
So in terms of redundancy, so I actually haven't looked too much into redundancy itself in
Mhm.
Storm. Well, I think the way that people handle that is looking at Storm's delivery guarantee. So if you do your message hacking appropriately, Storm will guarantee that that tuple gets processed. In terms of reliability, is if you make sure that you have enough supervisors in your cluster, enough raw capacity, if one of those supervisors goes down, Storm would spin up new instances of your bolts on the existing available hardware. So you achieve resiliency that way.
Brandon, you want to do more code? Can you show us how to plug into Twitter?
Oh man.
I don't know.
And then if time allows, I don't know if we can take it offline if it's not interesting to group, like the comparisons between Storm and Spark, streaming or Kinesis, if it's.
Yeah. So I'm not too qualified to talk about Spark really. I've actually just started playing with it. I know that Spark is doing some really cool stuff with streaming SQL, along with streaming analytics, and Azure is doing some streaming SQL, which is cool. I know Spark has support for the same graph style processing, directed acyclic graph that Storm does. But my understanding is Spark is much more than Storm tuned into the data science community, as is kind of a successor to Hadoop, and it is plugged into Amlib and some other libraries out of the box, I believe.
Mm-hmm.
I
So
don't know
like
if-
4 libraries, I think they ship out of the box on top of the Spark core, right? It's got like Spark SQL, Spark Streaming, Amlib, and GraphX. I think
That sounds right.
yeah, those are the 4 things they ship out of the box.
Yeah. I don't know if anyone else has played with Spark.
There's at the PyData Seattle meetup on the 24th, image analysis with PySpark. If you guys are interested.
There's a weekly Spark meetups as well. I think they do 2 a week. This they have for the last month or so. But they're in Seattle. It's a little bit of a drive, but my understanding between the differences between Storm and Spark is that Spark's much more event-driven. Storm is more, what is it, I guess? You define what you would be like the topology or the tree yourself, and if you need to change that tree, you likely usually need to redeploy.
Mm-hmm.
But with Spark, you kind of define what to do with the event as they come,
Mm-hmm.
and that topology kind of develops itself.
Okay. Yeah, I can see that because here you actually define how in your one class you define how it's all stitched together, right?
Mm-hmm.
It's kind of like the workflow type definition
very
within the code
procedural.
itself. So your topology is defined in code here.
Yeah,
Yeah.
and then like Spark is kind of,
It's a
I'm hand waving
stream.
thing, but it's an event sort of like, what do you do with this event, and then you send it to some other node, and then what does that do with the other, like, so it's kind of more dynamic as far as the actual topology of where those events go. And there's trade-offs between the two, but we could probably get some references or something next time to, but I think there's a lot of blogs and stuff on this already.
Yeah. I'm in the process of standing up a Spark cluster now, so I
Me
can say
too.
more next time.
We should trade notes.
Yeah.
There's
That'd
also
be
a
great.
couple nice tools called Sparkly, that's sort of a data analysis thing that plugs into Spark. And there's also meetups pretty much every
Yeah, it was the one
2 weeks
I
or
was at the
so.
one in Seattle.
Okay.
It was pretty good.
Is that with Felix Chump?
Yes, but they covered X frames. So they basically wrote a data frame, like pandas in Python. They wrote that over a Spark cluster, so it's pretty cool. Normally you work in Python and you're doing data analysis with pandas, it's all running on your machine, right?
Yeah.
It feels like that, but it's actually running on the cluster. So you could be like manipulating data and it's just running out on a, on a multi-node cluster. So it was pretty cool in the demo.
What was that called, I'm sorry?
It's X-Frames. There's a company in Bellevue, they're writing libraries, and they X-Frame, they open sourced it for that one particular library. So the engineer who wrote it was there talking about it.
Which company is this?
I don't remember the name, I'll look.
So I have a question on the aggregation. So you mentioned that aggregation on a key happens on one instance of a board.
Yes.
So what if there is a skew in the data which is coming in?
Yeah, that could be a serious problem. And so, so Storm doesn't, it doesn't have any way to handle skew problems in real time. Yeah, and I think you would have to sample your data, figure out the skew. If that was a serious problem in your data, you can implement a custom grouping, and in there you can handle skew problems. So write your own hashing function to more evenly distribute the load.
So if I do know that there is a skew, maybe let's say there is a skew in the URL and I need to aggregate on the URL, I'll have to construct my topology accordingly.
Yeah, so there's, I guess that there would be a few ways to do it. So one is, if you increase the number of tasks for that pool to a sufficiently high number, that will help distribute the load and reduce any problems that you might have with skew. But if you can't solve it that way, then yeah, you'd have to look at writing your own grouping function to say, like, if you know that 90% of the data comes in for a specific value, you could literally just hard code it and say, send the value of that to one task and send everything else to another task. You could also do something to try to break that down into separate keys, potentially. If you can, and if you don't need to have everything in memory for that specific value.
Let's give Brendan a round of applause.
Thanks for coming, everyone. I hope that was helpful for anyone interested in Storm.
I'm not doing anything Twitter class.
And then we can get into hacking now.
I'd actually be more interested in doing the streaming audio process.
Let's do it.
I'm curious. So I'm curious.